The first technology guide in this class is going to cover computer hardware. A lot of you are already familiar with the hardware because you use it all the time. What this is going to do is to give you a vocabulary for what you already know. I imagine most of you know what memory is and you know what a processor is. For some of you this is going to be extremely basic. For others of you it might help you to understand a little bit about how the computers work that you are actually using. The outline of this talks about the central processing unit. It's just sort of good to know. I'm going to show you a little bit about that in just a minute, but the CPU is nothing groundbreaking here, but it's just information that helps you to understand how your computer operates. And the model that they show here is pretty much every computer that's ever been built has been built off of this framework. And it's going to talk about computer memory, the difference between primary and secondary storage, and there's a lot of different directions that all of this is going, and that's sort of what I want to concentrate on in this short video here, and then some different input and output technologies and innovations. Let me scroll down to the picture here of the central processing unit. This is, as I said, an image of basically how every computer that's ever been built operates. You've got some input request from the outside from the computer. The white box would be the computer, the blue box is the actual processor. But you've got some input coming in from the keyboard, from a mouse, from a microphone or a camera, and your processor will take that input and then it's going to run this cycle over here: fetch, decode, execute, and store. It has to go and get instructions from the primary storage. Then it has to decode the instructions, execute the instructions, and then store the result either in the register, primary memory, or secondary memory. So that's sort of your outline of how it works. But what happens is you don't have enough storage in your primary memory for all of your applications. So they're all stored in secondary storage. There's some reasons for that you'll find. It's called volatility. Look up volatility in the book and you'll see the reason why all of your programs are stored in secondary storage. Now the reason it takes your computer a while to boot up is because it's taking those instructions out of secondary storage and putting them into primary storage, or your main memory, also called a lot of times your RAM. The more RAM you have, the more programs you can have open at one time. You probably haven't seen it in a while, but you probably remember within the last 4 years at least using a computer that had RAM that was such a small amount of RAM that you would get this blue screen that said there's insufficient memory to complete the action. And what had happened is you had filled up the primary storage and it had nowhere else to put any more instructions, and therefore there's no way it could know what it was supposed to do. So you'll pick up on that as you read through the chapter and read through over the PowerPoints. It's a very straightforward chapter. Of course, then after it completes the execution, it's going to save it in some form of output. It could be that you print it. It could be that you just view it on a screen. There's a lot of different forms of output today. There's communication devices. There's modems that you're all using all the time to send information from one computer to another. So there's a lot of things that go on here inside the computer. And as you read through this, it'll just help you to understand some of it. And it will also help you if you're ever shopping for a computer, or if someone asks for your advice on what type of computer they should buy. You'll be able to give them some more educated information. The text does also talk about Moore's Law, and it talks about the complexity and microprocessor design and how it's doubled and how it's growing. But this is what's really interesting, is this is a prediction that by the year 2020 to 2040, somewhere around there, that computers will be as fast as the human brain. I don't know that we'll ever get there. And if we do, I still don't believe that a computer will ever outperform a human brain. Now, there are some things that computers are much faster at than we are. For example, all of us can do long division. A computer can do long division a lot faster than we can. But when it comes to more complex issues, such as facial recognition features, you just think about it. The next time you're walking through the airport, you pay attention. There's a pretty good chance that you are subconsciously scanning faces as soon as you see them. And when you see a face, you recognize that you either know that person or you don't know that person. A computer, though, would have to take that face and it would have to scan it against every image in its database and compare it to see if it knew who the person was. Now, we can do that a lot faster. We can scan, walking down an airport, you can scan hundreds of faces in a few minutes, and you might pick out the one person that you think you know. You may not remember their name, but you recognize them. The computer cannot do that yet. Then the text talks about computer memory, primary, secondary storage. I want you to get familiar with all this, the kilobytes, megabytes. It's just good to be able to speak the language and to be able to say the right thing when you're talking to people. So I want you to understand all of this. This stuff is not difficult at all. It's not rocket science for sure, but it does help you to understand what's going on inside your computer. So there's some good pictures here so you'll know kind of what some of this stuff looks like. Some of these things you're familiar with. You're getting more and more familiar with this technology like flash drives. These images here are even outdated with a compact flash at 2 gigs. They've got those now that are available up to 8 gigs. The USB drives, I've seen a 32 gig USB drive. And this is a little, I think it's maybe 512, is that what it says? A little tiny drive. Well, they've got those now that are just, I've got a small one. It's about that size. It's 8 gigs. And so it's just amazing the amount of space. So what I want you to think about as you're reading through this and learning about it, and they talk about the evolution of storage and everything, is what are the possibilities going to be when processing power is practically infinity. Now, it's not ever going to get there, but when any program that you can think to run, there's a processor fast enough to run it. Okay, now also consider the impact of storage going to infinity and the size becoming just minimal. What can you do with processors that do not have limitations and storage that doesn't have limitations, even size? So there's a lot of opportunities there for things to open up. One of the markets that's going to be changed soon, that's changing now, is digital cameras. Right now you have to put a memory card in a digital camera. You have to take the memory card out and put it in your computer to get your pictures off of it. There's a company, I recommend you all look it up if you haven't, called EyeFi, EYE-FI. They've built a 2 gigabyte SD card that has a wireless modem built into it. You put it in your camera and it automatically connects to your home wireless network. As soon as you take a picture, 30 seconds later that picture is transmitted over your home Wi-Fi to your desktop. And that's been rated one of the top innovations for the past 3 years. Now think of the applications for that. For the applications of being able to take a small device, as small as a postage stamp, and include it in different devices around your house that will automatically transmit information over your wireless network. There's a lot of possibilities. Now take that same concept and apply it to a business. Whether it's let's see, RFD, RFI, RF tags. I think it's just called RF. The RF tags that they're looking at putting on inventory, or if you put something that's the Wi-Fi on inventory, a small chip that you include in, even as small as a sticker that you could stick it onto something like a price and use that to check out rather than barcodes. There's a lot of possibilities coming. So think about that as you're looking at the changes here in this chapter. It's an interesting read. It's an easy read, and so it'll just kind of give you a little bit of history and see where everything's going. So you'll enjoy reading the text, I think. If you have any questions, just shoot me an email or give me a call.